the plan, let's go through these 3 problems that I asked you guys to work on. So take yours out. We'll kind of go through these as a group. I'll take some answers from you guys. And if you see anything that you don't understand or you think is going on that's wrong or whatever, feel free to stop me and ask. Sound okay? All right, so if I'm asked to graph these things, the first step that I'm going to do is write down my values for A, B, H, and K. So my value for A in part A is 2, B is, H is negative pi over 4, and K is negative 1. Good. The next thing I'm going to do is write my transformation map. And the format of that map is this. So for this case, we're going to have xy goes to x minus pi over 4, 2y minus 1. Everybody happy so far? Good. Now I'm going to write down the key points for sine, and I'm going to apply this transformation map to each of those key points. Everybody okay to this spot? All right, so I'll now plug in my x's and y's for each of these. So here, to do pi over 2 minus pi over 4, what do I need to have? Common denominator, right? So what is that common denominator going to be? 4. So I can multiply that first fraction by 2 over 2. So when I do that, I have 2 pi over 4 minus 1 pi over 4. That gives me just pi over 4. Then I have pi minus pi over 4, 2 times 0 minus 1. And pi minus pi over 4 is easy, right? 1 minus 1/4 is 3/4. Pi minus pi over 4 is 3 pi over 4, right? And then kind of just keep on going, you know. Just plugging in my formulas. Okay. So here again we have 3 pi over 2 minus pi over 4. Oh no! What do I need? Common denominator. What will that common denominator be? 4. So I'll multiply that first fraction by 2 over 2. So I really have 6 pi over 4. And when I subtract 1/4 from 6/4, I get 5/4. So we have 5 pi over 4. And then negative 2 minus 1 is negative 3. And I keep on going. And the last one is 2 pi minus pi over 4. Well, 2 pi is really the same thing as 8 pi over 4. So when I subtract this, I get 7 pi over 4, negative 1. Everybody happy with how I got those key points? Cool. Let's graph this thing now. So the big question becomes, what do I want to go up by on my x-axis? Notice that all of my x values are all like fourths of pi. So it seems pretty natural to just have the x or the x-axis go up by 1/4 of pi. Sound good to you guys? Yeah. So to get all the way to 2 pi, I need to have 8 of them, right? So 1, 2, 3, 4. 1, 2, 3, 4. And why did I want to go out to 2 pi? Because that's what the directions said to go out to, right? Okay. Let's start plotting some points. So here is negative pi over 4, negative 1. Here is positive pi over 4, positive 1. Here is 3 pi over 4. Whoop. Negative 1. Here is 5 pi over 4, negative 3. And here is 7 pi over 4, negative 1. Where would my next spot be at? Yeah, it would be here, right? Where we're going 2 1/4 pi's over, like 9 pi over 4, and then positive 1 would be the next one. Why did I need to include this last point on there? I need to go past 2 pi, so I just wanted to make sure that I had one more point on there. And I just did it by kind of following the pattern. So there's that. Everybody happy with that? So not so bad. Let's see. What was B? Can somebody just tell it to me so I don't have to scroll all the way back up there? Okay, I couldn't hear what that mumbling was. Negative 3 tan. Okay. Boy, I was mean. Okay. So, yes. Yes. What I want to do is to find the values for A, B, H, and K. But before I do that, I should do something else, right? Which is just rewrite this in standard form. Not if you get the correct value still. So I'm going to factor that 1/2 out. So now I can find the values of A, B, H, and K relatively easily. A is negative 3. B is 2. H is pi over 3. And K is 3. So again, by not writing it in standard form, it's easy to mess up what the H is. So that was my, well, if I do pi over 3 times 1/2, I get pi over 6, because I just multiply across, right? So it's just, it's that simple. Okay. Now that I have that, I can write my map. So again, the map always looks like bx plus h, ay plus k. So in this case, it is 2x plus pi over 3, comma, negative 3y plus 3. Everybody's all right there. Okay. Then I'll go to my key point sheet and look at the key points for tangent. Unfortunately, I don't have those memorized like I do for the other ones. For sine and cosine, anyways, I use those so much. So I'll just take a quick peek. Okay. I remember those. I don't remember. I lied. Is that 1 or negative 1 there? 1. Oh, negative 1. Good. Okay. That's what I was going to thought it would be. So I wrote down my key points. And now I'm just going to plug those into my math that I wrote. And I know that anything we do to undefined still ends up undefined, so I'm not going to bother writing negative 3 times undefined plus 3. I'm just going to write undefined because you do whatever you want to undefined. It doesn't have a definition, so no matter what you do to it, it's still not going to be defined, right? So it doesn't matter what you do to that. The one exception might be if you're talking about reciprocals, right? Where the reciprocal of undefined was 0 we saw earlier, but that's not an operation we're doing here. So, when I do 2 times negative pi over 2, I get negative pi, and negative pi plus 1/3 is negative 2/3 pi. Everybody, I hope we're okay with the simple fractions there, right? If it's just a whole number, it's usually pretty easy to handle. Now we'll do another one. So this part is going to turn into negative pi over 2, right? So to add negative pi over 2 to positive pi over 3, I need to have a common denominator. That common denominator would be 6. So I'd have negative 3 pi over 6 plus 2 pi over 6. So I'm going to get just negative pi over 6, comma 6. Everybody happy with that? Okay. Oh, 0, 0. Thank you. That'll be easy to handle. So when I plug that in, I just get pi over 3, comma 3. So far, is everybody all right? We're doing okay? Again, stop me if you're like, I'm not sure what you did there, but we're just kind of doing some adding and subtracting right now. So it's not too big of a deal, but if you need to talk about it, by all means, make yourself heard. Okay, so when I multiply these two together, I get positive pi over 2. So to add pi over 2 and pi over 3, I need a common denominator. That common denominator would be 6. So I have 3 pi over 2 plus 2 pi over 3 pi over 6 plus 2 pi over 6 to give me 5 pi over 6, and then negative 6. And then my last one, 2 times pi over 2 plus pi over 6, pi over 3, and then, oh, that just undefined. Everybody okay there? So when I do 2 times pi over 2, I get just pi, and pi plus 1/3 is just 4/3. So there's my transformed key points. So now I'm going to go ahead and look at my x values and try to figure out what I want to go up by on my x-axis. So if I look at all my x values right now, I notice that they don't all have the same denominator, right? What I'm going to do is I'm going to rewrite them so that they do all have the same denominator. So instead of thinking about negative 2 pi over 3, I'm going to think about that as like negative 4 pi over 6. And instead of pi over 3, I'm going to think about that as 2 pi over 6. And then instead of 4 pi over 3, I'm going to think about that as 8 pi over 6. And then I'm just going to go up by sixths of pi on my graph. Everybody okay with that reasoning there? And again, the only reason I'm doing that is just so it's easy for me to count on my graph on where to put things. Yes, Megan? Pi over 4. Okay.
Yeah, okay, so in all of the other ones, you added 0 and
Oh my goodness, thank you. Yeah, so what Megan has pointed out is that this was supposed to be a plus 3, so this should be 0 for the y-coordinate. Thank you. I thought something was fishy there, but I looked at it twice. I'm like, nope, negative 3 minus 3 is negative 6. It would help if I copied the rest part of it wrong, so thank you, Megan. Yes, you're correct. Good catch. Something would have been fishy there in a minute when we started graphing. All right, so let's start to do that. So if I'm going out to 2 pi here, I need to count 12 tick marks. So 1, 2, 3, 4, 5, 6. That's a pi. 7, 8, 9, 10, 11, 12. There's my 2 pi. And then we have to go 1, 2, 3, 4, 5, 6 as my high one. But I need to go somewhere to the left, right? I need 4 of them to the left. 1, 2, 3, 4 to the left. Everybody so far so good? Okay, when I graph these ones with the asymptotes, I like to draw in the asymptotes first. That's my personal preference. So I have negative 4 pi over 6 and positive 8 pi over 6 that I'm going to draw in my asymptotes for first. So then that's negative 4 pi over 6, and 1, 2, 3, 4, 5, 6, 7, 8. Everybody happy there? Okay. And my next one is at negative pi over 6. So that's here, comma 6 is that point. And then I have 2 pi over 6, and then 3. So that's this point here. And then the last one is 5 pi over 6, and then 0, which is this one here. So I'm going to draw this part. So it's going to look something like that. Now I'm going to draw in and extend stuff out here. So I'm going to extend this a little bit, possibly. Let's start by just putting the next point. So if I count from the asymptote, if I go 1, 2, 3 spots at 6, so I'm just going to do the same thing. So I'm going to go 1, 2, 3 spots from the asymptote, and at the y value 6. But I'm still not past 2 pi, so I'm going to extend this a little bit so that I can do the next one. So I'm going to do, again, 1, 2, 3 spots, and then down at 3. And then that's enough to cover me past. So I'll just do that much. Is everybody happy with that? Again, if you wanted to do more, you could kind of keep going and it does something like this over here somewhere. But that part didn't matter because I've now passed 2 pi. But if you wanted to, if you felt better about doing that, feel free. Megalicious, you have a question? Are you talking about this point? This point? I said, okay, I'm starting now over, so I start at my asymptote, and the next spot is like 3/6 of a pi, because I just started here and went 3 pi over 6s. So I did the same thing here, 3 pi over 6. Does that make sense? So I just kind of looked at my pattern and just kind of started doing the same thing over again. So it's very much like you could plug in from the key points for tangent, right? We have more than one period's worth of key points on the key point sheet, so you could have done that too. You could have taken the next key point off the key point sheet, which I think is 3 pi over 4, and -1, and plug that in too. That would have been okay also as an alternative, but I'm of the mind that like counting is easier than plugging stuff in and adding fractions. So I just said, I'm just going to keep counting and following the pattern. But certainly you could have plugged in too. That's nothing wrong with doing that. Is everybody satisfied with this one? Yes? Okay. Can somebody read for me the equation to C? Okay. So, again, first thing I want to do is determine my A, B, H, and K. But to do that, I'm going to start by writing this first in standard form. So I'm going to factor that 2 out. Everybody happy with how I got to here? Stretch or question, B, me? Okay. All right. Yeah, maybe? So again, you have to think about, this is, if I distribute this back in, I do this, which reduces to pi over 8, right? Right, so that's the same thing as dividing by 2, which is the same thing as multiplying by the reciprocal. Oops, that was an 8 there, which is still the same thing as this kind of thing. You know what I'm saying? Okay. Good questions, though. Again, like, be careful on that factoring step there, is it's easy to kind of screw that up. And if you screw up that H, like it screws up everything afterwards. So the A value here is -2. The B value is 1 over 2. The H is pi over 16. So that was Maddie's exact question that we just talked about. So again, when we factor that 2 out, you are doing pi over 8 divided by 2, which is the same thing as multiplying by the reciprocal, right? What? No. This is the way you'd write it. So when you factor it out, whatever that coefficient is goes out, and the b value is the reciprocal of that, not the other way around. Factoring it out doesn't make the reciprocal. Finding the b is what makes the reciprocal. Is that okay? Took me a minute to realize kind of what we're driving at there, but that's okay. I'm glad that we got that straightened out. And then the k value is -2. That part everybody should feel good about. Okay. Now that we have that sorted, we're ready to write our map. And again, every single time, our map looks like this. So when we plug these things in, our b value is 1/2. Our h value is -π/16. Mr. Kulik, you're a jerk for picking such a horrible looking fraction. So far, so good. Okay, now on to the key point sheet. And we're doing a cosecant one, right? All right. So, unfortunately, the is that really π/6? Or no, it's 1/2. Okay. And we're just gonna kind of copy some stuff down. We're just copying stuff down off of the key point sheet. It's so much fun. It's not really any fun, guys. 11π/6, -2, 2π undefined. Did I do all those right? Yes, it looks like it. This is exhausting already, guys. I know it. I picked the last one. Isn't that always how it works, though? Like the last problem? Like you're already tired, and it's like, oh, this is exhausting. I don't want to finish it. I do it that way rather than the first one because at least maybe you'll do 2 of them. If I started with this one, you probably all would have quit by the first one after the first one. So you try to pick the hard one at the end so that at least you finish the parts before it. Okay. So let's do some plug-in here. So I have 1/2 times 0 minus π/16, and then undefined. So that's just -π/16 undefined. We okay with that? Okay. So I have 1/2 π/6 minus π/16. -2 times 2 minus 2, and I already regret not giving myself more space to do some scratching. I'll just probably do it over here on this side. So that's going to be π/12 minus π/16. Who sees the common denominator between π/12 and π/16? It's going to be 48, I think, right? 3 times 16 is 48, and 4 times 12 is 48. So that becomes literally π/48. Oh my God, Mr. Kulik, are you serious? Yeah, I picked a doozy for you guys there. Okay, continuing on. At least this one's not so bad. So that's going to be pi over 4 minus pi over 16. That's easier to see, right? What's the common denominator going to be there? 16. So that's just going to be 4 pi over 16 minus pi over 16. So that's going to be 3 pi over 16. We okay with the fractioning? I mean, it's just kind of unfortunate numbers, but the fractioning isn't, should be something we can do. Negative 2 minus 2? That's okay. Good. If you think something's up, ask the question. Nothing wrong with doing that. Yes. Yeah. I'm just writing too small, huh? I can do one of these. Does that help? So again, we have the same situation that we did earlier. So if I'm going to do a little scratch work on the side, we have 5 pi over 12 minus pi over 16. The common denominator here was 48. So that's going to give me 20 pi over 48 minus 3 pi over 16. So that's going to be a really gross looking 17 pi over 48. And then that's just going to be pi over 2 minus pi over 16. So that's going to be 7 pi over 16. I just did that one in my head and spared you guys having to look at it. Everybody okay so far? Can't believe we're only halfway done with the key points here, though. Oh my gosh, it's horrible. It is pretty bad. The cosecant and secant ones are tons of fun. So let's see what we have here. So we have 7 pi over 12 minus pi over 16. The common denominator here is going to again be 48. We've seen this a couple of times now. So that's going to be 25 pi over 48, and then 0. Oh my gosh, that's not 0, that's 2, dummy. Sorry about that. This one's going to give me 0. But again, we have a common denominator situation here. Let's just kind of sketch some stuff on the side. So that's 3 pi over 4 minus pi over 16. Common denominator would be 16, so that becomes 12 over 16. So that's going to be 11 over 16 pi. Or 11 pi over 16, excuse me. Ugh. And the last tough one here and then we have just scratch work on the side here. 11 pi over 12 minus pi over 16. My common denominator will be 48, so that's 44 pi over 48 minus 3 pi over 48. So that's going to be 41 pi over 48. And my last one is going to be 15 pi over 16 undefined. Whoa! Guys, who's tired? Yeah, that's 11 pi over 16. 41. Which one is supposed to be 15? You said over 48? No, it's over 16. Pi minus pi over 16 is 16 pi over 16 minus pi over 16, which is indeed that, right? Yes. Okay, so this looks pretty horrible. Let's make it doable, though. What I would do first is, notice that if I look at the x coordinates here, they have different denominators. What I'm going to do is rewrite them so that they all have the same denominator. That common denominator will be be 48. Well, I might go up by 2s or something, but I'm going to think about them all as 48s. I'm just going to kind of see what I got there. Oops, that's a 0. So that's just me recasting these all with a common denominator. All the denominators are 48s. Oh, yeah, that's 21 pi. I thought, I'm like, well, all the denominators are 48. That wasn't the question you're asking. Now, going up by 48 seems like the natural choice, and you could do that if you wanted to, but God help you, I'm not going to draw 96 tick marks all the way out to 2 pi. That's positively exhausting. So I'm going to be doing a little bit more eyeballing. I figure I'll go up by 20/4. That's a 21 over 48. 21 pi over 48. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Wait a minute. This is part of it too. 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. I'm going up by 2. Yeah, so these are really 20/4. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 is out to 2 pi. Gross, Mr. Kulik! You are the king of the jerks. I would probably have worked it out beforehand and not make it such a pain in the butt. Yeah, that seems rather unreasonable. Yeah, you might need to do that. So I'll draw in my asymptotes now. I'm just going to draw them as solid lines because I got this thing zoomed out so far it's probably hard to see the diagonals. So that's negative 3 pi over 48. And the next one is at 21 pi over 48. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 21 is in here. And then 45, so that's 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 45 is right in here. And then we'll plot the things inside here. So we have this guy down here, and then 3, 4 there. Jerk. Gosh dang it. And then the other one is 16 here. So you have that part. And then you just kind of continue on. Am I out of time? It sounds like I am. So tomorrow I'm going to give you guys a review to work on in class for the section or the graphing test. And we'll plan on doing the graphing test probably on Tuesday next week. Just as a heads up, I'll put that up on Haiku.